Hello everyone. So today we discuss the polynomial thing, that is the theory of equation. Okay, so in theory of equation already Laha sir have taken some classes. Okay, I just recalling some of them. Okay, theory of equation. So basically you will see there are some important theorem. For example, the first one is an algebraic equation of n degree. N degree is the highest power, that x to the power n will be there, right? Maximum n. Okay, then this is called the degree. So it has maximum n roots and no more. Okay, so this is basically you can say fundamental theory of algebra, classical algebra, right? N equation have your maximum n roots. Next one is, if alpha be a root of the polynomial of the equation fx is equal to 0, fx is equal to 0 of order r, then you can say alpha is a multiple root of the equation f dash x equal to 0 of order r minus 1. For example, suppose if you consider a function fx is like x minus 1 whole to the power 5. So you see 1 is a root of 5, right? So if you find its derivative, what you have? F dash x is equal to 5 into x minus 1 whole to the power 4. So x equal to 1 is also root of your f dash x of order 5 minus 1, right? So in this way you can recall this type of thing. Basically I have seen in your exam theory is not coming directly, but in this chapter mainly 3 method you have. Okay, and this from this type of method 3 or 4 maybe, I think 2 almost coming. Okay, so we try to cover this point. Okay, now your next theorem is, if alpha be a real polynomial, has a complex root alpha plus I beta, then it has also its conjugate root also, right? So because if you have all thing is real, so if 2 plus 3i is a root, so 2 minus 3i is also a root, this type of property. Okay, next. Okay, so if your polynomial with rational coefficient, okay, if you have a rational coefficient, then if alpha plus root beta alpha plus root okay, rainbow, yeah, alpha plus root beta is a root, then you can say alpha minus root beta. But remember, this is this works whenever your polynomial is your rational. For example, if you have x square plus pi type of thing, so then this theorem is not work, right? Because your element should be rational. Next is your, if fx is a polynomial with a real coefficient, and if your alpha and beta are two distinct root, then and not distinct, the alpha beta distinct real numbers, such that if alpha and f beta are opposite in sign, then fx has at least one root which is lies between alpha minus beta. For example, suppose you are considering fx is a sum curve, fx is a sum curve. Suppose this is alpha and this is beta. They have given that f alpha and f beta are opposite in sign. So you can see f alpha is the negative, f beta is positive. So obviously in between that you have a one root, right? So in this way you can recall this theorem. Okay, this type of theorem prove, I think last I already done, or else you can find from the MAPA book. Okay. Next is your Descart rule of sign. What it says, the number of positive root with real coefficient does not exceed the number of variation of sign in the sequence of the coefficient of fx, and if less, it less by a even number. So what it says basically, suppose for example if you consider this example, fx is equal to this thing. Okay, so in the fx, what are the variation? Basically you see this is your plus, this is plus, this is plus, this is plus, this is plus. So no change in sign variation, right? So you can say whenever you are checking for fx, so basically this is represent the number of positive root, and if you are checking for f of minus x, that corresponding to the number of negative root, because you see they have written this is positive, right? So you have to check, you have to write in this way the sign variation in fx. So how it's type? Plus 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 plus. Okay, so no change in sign. Okay, so fx equal to 0 does not have any positive root, right? Now if you checking for f of minus x, what do you have? F of minus x, x to the power 6 plus x to the power 4 plus x square minus x plus 3. So what are the sign variation in f of minus x? So basically you see plus plus plus, this is minus, right, and then plus. So two variation in your, because here is a change, here also is a change, right? So two change. So there are two variation in sign. So whenever you have 2, so the number of negative root you can say 2, or it will be lesser by 2, that is either it has 0 negative root or 2 negative root. Okay, this type of thing. If it is only one change in your equation, then you can say it will be exactly unique 1, because you cannot say minus 1, right? 1 minus 2. Okay, if it is 3, then you can say it will be 3 or 1. Okay, if it is 4, then you can say this is 4, 2 or 0 in this range. Okay, so whenever it is lesser, you have to less by 2. So in this way you can say fx equal to 0 has either 2 or 0 negative root, depending on that all other root are complex. On that it has 4 or 6 complex root respectively. Why? Because you know it has maximum 6 root, right? So if it is 2, so 4 complex root. If it is 0, then you have 6 complex root, right? Respectively. Okay, listen. Okay, now you will see there is a, so Descartes' rule are very easy. Okay, so if this type of problem is coming, find the nature of equation, you can do in this way. This is also very, very important. So this is a thing that, or maybe like your I am writing with some number. So basically theory of equation TE1. Okay, next thing is your TE2. theory of equation 2, Sturm theorem. Okay, so this Sturm's theorem, I have seen only one of the previous year question. It may come. Okay, so for this one, I am taking this thing. So what you have to check basically here, first you have fx, then you have to find some auxiliary function. Okay, first you have fx, then you have to find the f dash x. After that, basically this type of polynomial is, I think, called Sturm function. Okay, so you start from your fx is equal to this one, x to the power 4 minus 12x square plus 12x. I think this thing is also discussed in your class. So this is your fx. Now after that you have f1x, that will be your f derivative of that, f dash x. This is very easy. So this is, you can have 4x cube minus 24x plus 12, right? Now you have to find similarly f2, f3, f4, up to what you are not getting a constant. Okay, you have to do. So how to find this f2, f3? Basically you have to divide your f1, divide your fx by f1, and you have to find what are the remainder you are getting. Okay, so you have to find the f2x, but what you will do, you will write that function only. You just write inside 0, and in the left corner you just trying to divide this thing. Okay, or you can do in your RAF also. Okay, because in your book, if you see, they will write that thing directly. And remember, fx and f1x will be like that. This is very easy. Afterwards, f2 and f3, whenever you are writing, you have to change its sign. Okay, and whenever you are doing your f2, you can multiply with any constant number or that type of thing, you can easily do. Okay, so suppose you are finding with division that 4x cube minus 24x plus 12, you are dividing with x square 4 minus 12x square plus 12x minus 3. Okay, so you see, whenever you are doing this thing, basically you have to do 1 by 4x, right? So we trying to avoid this type of 1 by 4. Okay, so better to you multiply with 4 the whole equation. So basically if you multiply with 4, so basically it will be 4, right, minus it will be 48, then you have 48, then you have minus 12. Okay, this thing you have. So then if you divide this thing with x, so what you have, 4x to the 4 minus 24x, then you have minus plus minus. So what you have, minus 24x, then you have sorry, 36x, right, minus 12. You know how to divide polynomial in the polynomial thing in this way. Okay, so I think you know this. Okay, now the thing is, whenever you have this thing, so you see here 6 is common, right? You can take 6 common, so I think from there you have 6. Yeah, 6 I can take common, no issue. So basically minus 4x square plus 6x minus 12, right, minus 2. Yeah, so what you have to do, you can to change the sign. I think 12 is also common. Okay, sorry, so minus 2x square plus 3x minus 1. So you have to change the sign. Okay, so from there you are getting what, 2x square minus 3x plus 1. So this is your f2x. Okay, now you have to find the f3x. How you will find? For the finding f3x, you have to divide 2x square minus 3x plus 1 this with 4x cube minus 24x plus 12, like that. Okay, so how you will divide? First you have to do with 2x, right? So 4x cube minus 6x square plus 2x. So if you do minus plus minus, so what you will have, this is cancelled. Okay, this is cancelled, this is cancelled. So what you have basically I have to add one more page. So basically what you have, 6x square minus 24x minus 2x plus 12, right? Now you see, still you can divide, right? So you have to add plus 3, so you have 6x square minus 9x plus 3, right? If you do minus plus minus, so this is cancelled, so you have what, I think minus 15x. Am I doing any mistake? Sorry, minus 24 and minus 2, this I can add, right? So it will be 26. Why this is not normal? Because this and this have same thing, right? So this is not there. Okay. So more minus 2, so minus 17x, right? Okay, so this is you have. So from there you have an idea. So this is like what is your function basically. If 3x you can choose minus 17x minus 9. You remember I am changing the sign, right? Yeah, I think this thing I can write here. If you write in the exam paper, so you can write in this way. So this is you have, so changing sign, two x square minus 3x plus 1. So therefore you have, this is your f2x, right? This is your f2x. Okay, no issue. So f3x this. Now how to find f4x? Basically you have to do 17x minus 9. This is you have to do 2x square minus 3x plus 1. So you see there will be some fraction like thing, right? So you can multiply with 17. So it will be like 34x square minus 51x plus 17. Now you can do it 2, right? 2x is equal to 34x square minus 18x. So minus it will be minus plus, so it you have what you have, 51 plus 18. So plus 18 means 43, 33 minus 33x plus 17. Basically you have to check the sign, no issue. So you have to do it minus 33 by 17. So if you do so, minus 33x minus minus, right? 33 into 9, what you have, 297. So 297 by 17. Now you have plus minus, so you have 17 minus this type of thing, right? So I think 289, right? 17, yeah. So minus 297, that means negative is more, right? So 217 square. If you do simple calculation, so 17 into 7, 289. So 17 minus 297 by 17, right? So 289 minus 297 by 17. So what you have? Minus 297. So minus 8 by 9. So if you change the sign, so you have plus, right? So this is basically you have to check. This is, you can multiply any factor or division, that you can allow. Okay, so changing sign, you have basically, you see, changing sign, if you multiply with 9 by 8, so you have minus 1. Changing sign, it will be 1, so your f4x is your 1. So in this way you have find all the Strum function. Okay, now you have to make a chart for all the thing. Okay, this is little bit lengthy also. So first you have fx, or I think am I written fx I have started. Then you have f1x, then you have f2x, then you have f3x, then you have f4x. Okay, now you have x value here. Okay, now you have to make, you have to check the sign. Okay, so they are provided, you have to check in the minus 4 comma 3. So first you have to check what are the minus 4 number of change. Okay, 3, what are the number of change. Okay, in this way. Okay, you just check in this problem what are the sign you are getting. First minus 4 and 3, you just find the value of f of minus 4, is it positive or negative. Okay, in this way you find this one, and after that we will continue in your next class. Okay.